Hi friends, welcome to Civil Engineering and Programming channel. After a long gap, I am making a video and demo on how to find the nodal weights of the building. Nodal weights of the building. Okay, let me open this first. Slabs, one way or two-way slabs. Just you click on this, then you will get a pop-up window like this. Then you go for a little bit about theory about slabs. Okay, depending upon its aspect ratio, that is Ly by Lx, the slabs are divided into two types. One is one-way slab and two-way slab. Okay, then let us click on this load distribution diagram of one-way slab. This is the load distribution diagram of the one-way slab. Okay, this is Lx and this is Ly, that is shorter span and longer span direction. We can see how the load will transfer off. Okay, like this, half of the load will be transferred in this direction and half of the load will be transferred to into this direction, from the slab to the beams and from beams to columns. Okay, then we have to find how much the load is transferring to these beams. Okay, this beam and this beam, then the formula is capital W is equal to small w into Lx, that is this Lx by 2, that is kilonewton per meter, where the small m values are in kilonewton per meter square, okay, that is W includes dead load, live load. Okay, this W, small w, includes dead load and live load, both loads. Okay, this is the formula. Then coming to two-way slab, you can see, click on this load distribution diagram of two-way slab. You can see here, there are two types of loads. One is the trapezial load, another one is the triangular load. You can see for triangular load, the load is capital W is equal to small wx by 3 kilonewton per meter. Okay, and trapezial load falling on this beam is W is equal to W Lx into 0.5 into 1 minus of 1 by 3 c square, where c is nothing but aspect ratio of this slab, that is Ly by Lx, longer span by shorter span. This is the formula we have to use. How much trapezial load is falling on this beam. Okay, let me first let us calculate it. You can click on this load calculation of a slab, then you will get a pop-up window like this. Then you have to put the live load on slabs. Live load on slab is, let us say, 3 kilonewton per meter square, and floor finish load on the slab is 1 kilonewton per meter square, and width of the long beam I am taking as 0.3, and the depth of the long beam is 0.3, and width of short beam is 0.3. I am taking the same. With depth of shorter beam is 0.3, and thickness of the slab is 0.15 meters. Then we have to give the Ly direction, that is the longer span of the slab, that is 8.83 meters, and the shorter span of the slab is 0.15 meters. Okay, just you click on this calculate nodal weights. Just you can see a 2.8031, that is obviously one-way slab. Okay, this is the we have to design this slab as one-way slab. You can see here, these are the 67.37 kilonewton, or the nodal weights which is acting on the this columns. Okay, therefore we can do any number of uh, if you want to calculate the nodal weights for different types of slabs, whether one way or two-way slab, this very simple software will save us time. Okay, save us time. And therefore if you do the cumulative sum of all the stories of this nodal wires, then you will get the load acting on the footings. Okay, therefore for practical purpose, this nodal weight calculation is very useful to design the footings as well as the columns. Okay, columns, and this nodal weights is a calculation is also very important in those who are involved in earthquake engineering. uh, by using some other tools like iDark 2D, or uh, there are many other tools are like OpenSeas tool. We have to find the nodal weights. Therefore this software is very useful for earthquake engineering purpose also. Okay, just you click clear, you go for other let us say 4. Okay, just 2.20. So we got 82.87 kilonewton. These are the loads, the loads, nodal loads from the slab to beam, and from beams to columns. Okay. Okay, this is all about how to calculate the nodal weight calculations from slabs. Okay, from slabs onto the beams and to the columns. Okay. Okay, let me change the width of the long beam as 0.35 and depth of the long beam as 0.75, and the width of the short beam is 0.3 and the depth of the short beam is okay as 0.3. Then let us calculate what will happen. 97.77 kilonewton we got. Okay, these are the nodal weights acting on these 4 columns from this slab. Okay, from this one-way slab. Okay, anyway, thank you for watching this video. Thank you.